So we're ready to start a lesson on chemical bonding, and actually we're going to have several lessons about chemical bonding. We've got chemical bonding here where we're going to talk about covalent bonding first. Okay, so there's different ways that atoms are held together, and the way they're held together in these tight means there's a couple different ways. Okay, and when you are holding things together, they're trying to obey the octet rule that we talked about already. And these atoms want to be like the noble gases. They want to have the same electron arrangement as those noble gases. So to do that, we call this the octet rule because those noble gases, except for helium, they have 8 valence electrons in them. So 8 is, octa is, octagon, an octave, an octopus. This is a word for 8. So the octet rule is where these atoms are trying to obtain the same arrangement as those noble gases and get 8. Now, how do they get to 8? Well, they can do it by gaining electrons. Let's say they only had 6 and they need 2 more. If they could gain 2 from somewhere and grab 2, that would be one way. Maybe they've got a couple extra hanging around. If they could just get rid of those, they'd drop back and be like the nearest noble gas, so they could lose them. Or they could share. So, as you get kids going into the sandbox and they want a bucket to play with and they want a shovel, and one brings a bucket and one brings a shovel, one way they can both be happy is to share. And so if we've got one guy who's got 6 electrons and needs 2 more, and this guy has 6 electrons and needs 2 more, if they could pool a couple together and say, all right, let's share these guys, we can both feel like we have 8. That's the other way that you can form these tight connections between them. So in covalent bonding, it's the sharing that we're going to look at first. Okay? So we have to know when is it going to occur. We can see why it would occur in order to get to that octet being satisfied. All right. Before we get into that in detail, let's talk a little bit about chemical properties. Chemical properties of an element, is what it says here, are primarily determined by the number of electrons in the valence shell. So we learned how to look at the periodic table, and I have a periodic table here, okay? So, you can't see all this, but we learned how to look at this periodic table and determine how many valence electrons an atom has. Everybody is the same in a group going down or has similarities because they have a similar number of valence electrons, okay? So we're going to talk about the covalent bonding in this lesson. Later we'll talk about the ionic bonding, where you're not sharing electrons, but you're doing a swap of electrons. Somebody's gaining, somebody's losing, and they're both getting happy by doing that. Okay. Let's go on to the covalent bonding, the sharing. Okay, so let's consider the simplest case. If you were to look at a periodic table and find hydrogen, hydrogen is in the top left-hand corner, okay? That hydrogen there we learned was in the 1A family, and we learned that it had 1 valence electron. So what we see represented on the screen here is that 1 electron, and I'll move on over to it and kind of circle that electron. This is the electron that is in its outer shell, and it only has 1 electron, and I'll call it E-. That's not happy. The nearest noble gas is helium, and helium has 2 electrons. So while, the octet rule is the octet rule, helium is the role model for hydrogen. It's its closest noble gas. It only wants 2. So over here is a hydrogen atom, and it only has 1 valence electron. Okay, and he's not happy. But if those 2 guys could get close enough together to where they both felt like those 2 electrons were theirs, then suddenly the hydrogen would be happy. Now, those 2 electrons don't just hang out in between them like that. It's more better, let's not say it that way, it's better, and I'll represent it like this. Here's the nucleus of one hydrogen atom, here's the nucleus of another hydrogen atom, and there is a space that they share where those 2 electrons are buzzing about. So those electrons are spending time at both guys' houses and both are claiming him. So both nuclei, both hydrogen atoms in a sense, are saying those electrons are mine. Both of them are getting a sense that they are like helium. And that is covalent bonding is all about, the sharing of electrons. Okay, so anytime you share two or more electrons, and it's always going to be those valence electrons, the ones that are in the outermost shell that can get shared, then that is what a covalent bond is, the sharing of electrons. Now, as soon as you share something, you have something that's holding you together, and that is the attractive force of these guys. So a covalent bond is an attractive force holding these atoms together. All right, now how do we represent that? There's different ways to represent it. We wouldn't want to always have to draw the picture. So we can represent it this way. This looks like two hydrogen atoms, and this is the electrons that they are sharing, two electrons being shared, and that is fine. Another way to do it is to represent it with a line. And when we see a line, it is two electrons being shared. Now, I don't want you to think about them as holding hands, okay? It's not like those two electrons are holding hands. Once again, you have the nucleus, you have a space where two electrons are buzzing about. That is what is being represented here with that dashed line that we see here. Okay, so dots or a straight line both would represent two electrons. Whether or not it is two dots or a straight line, it represents two electrons. Now, hydrogen can only form one bond with another element. That's all it can do. Can't do any more than that ever, and you're going to be tempted. That's why I'm doing all of this. You're going to be tempted to forget that. Hydrogen is not trying to get 8. It is only trying to get 2, and as soon as it has that single line there, it has the 2 electrons it needs. Let's look at another example that involves hydrogen. We're going to look at an example that has hydrogen atom and the fluorine atom. If we look at the hydrogen atom, it has one valence electron in its outer shell because it only had one electron, period. But fluorine, if you find it on the periodic table, and it'd probably be a good idea to pause your video and look at your periodic table, drag it out if you don't have it. But if you look at it, you will see that it is then the, let's see if I can write, well, try this again, VII, the 7A family. We know it has 7 valence electrons. It's all the way over, almost towards the noble gases. And so it's representing 7 electrons in here. 1, 2, 3, 4, 5, 6, 7. Now it doesn't have 7 altogether. It has 9 electrons altogether. But we're interested in that valence shell and only has 7. And if we think about the octet rule, it wants to have 8. So it needs one more. Well, hydrogen doesn't want to give its electron away. Okay? It doesn't want to say you can have my electron because hydrogen wants one as well. So what happens is the one electron comes in from the hydrogen and one electron is coming in from the fluorine, and they're going to share those electrons. And if you follow the gray sphere here, we see that hydrogen then thinks he has 2, and that makes hydrogen happy. But let's count what fluorine now thinks he has. Okay? He has, and I'll count them with the numbers, 1, 2, 3, 4, 5, 6, 7, plus the 1 being shared by the hydrogen, 8. So he has an octet. So both of them are happy that way, and we can look at this and see that the fluorine is now going to have the octet. It will have the noble gas valence shell configuration, which means it has 8 valence electrons. So this is what covalent bonding is all about. Covalent bonding is about one atom and another atom getting together and sharing however many electrons, bringing them together and sharing whatever is needed to be shared in order to make both of them happy. By happy, I mean having a noble gas configuration. Noble gas configurations are happy states because they're low energy states. So anytime I use the word they're happy, I'm just saying they're in a low energy state, which is where they will always strive to be. Okay, so here's that picture of the HF. Again, we can represent that in different ways to represent the big picture, not have to draw the picture every time, okay? We've already talked about the happiness. Okay, so the fluorine is happy, the hydrogen is happy. We could draw it with a couple dots, or we could draw it with the line there, and that shows those electrons. Now, it's not showing all the electrons. To show all the electrons that are actually in the valence shell, what we can do is write it this way. or we might write it this way. Okay? So the dots that are between are the ones being shared, and those are the covalent bonds. That is a covalent bond. If you refer back to the image there on the screen, these dots are the ones that are not being shared. The fluorine is not saying you can have those. Only one of these inside here are being shared with the hydrogen. These are unshared electrons. They might be called unpaired. No, unshared, okay? Non-bonding. Sometimes they're called non-bonding electrons. I can't spell and talk. Okay. They're non-bonding electrons because they're not part of a bond, but they're part of the fluorine. So when I see it this way, I see that the hydrogen has 2 electrons. He's happy because he is like helium. We see that the fluorine has 8 electrons, and he's happy because he's like neon with its 8 valence electrons. Okay, if we look at our periodic table, and again, glance at it there, if you look at your periodic table, we see that the noble gases are on the far right with our helium, our neon, and so forth. Right beside it is the noble gas, this was the noble gases, sorry. These are the halogens, fluorine, chlorine, bromine. So if fluorine does this, the chlorine is going to do a similar thing, the bromine is going to do a similar thing, the iodine is going to do a similar thing. Look just like this in terms of non-bonding electrons and the bonding electrons in the sharing situation. So when you have elements in the same family, they behave chemically very similarly. They like to form similar compounds. Okay, we're going to stop for this, and we've introduced the idea of a covalent bond. What we're going to turn to next in our next video is learn about all different ways of representing things. This is called a Lewis structure, so I'll teach you about Lewis structures next.